right, again, I'll try to keep the amount that I read out of the book down to a minimum. Plus, when we get to about 5 after 9, 10 after 9, we'll take a break, and then we'll continue on after the break. All right. What they're saying is, in the first two chapters that we went over, chapters 2 and 3, it says you learn to code some simple but unrealistic applications using the prompt method. In other words, it's much easier as we start to bring this forward to take what we've already learned with HTML and create a form, and then be able to use the stuff in the form and manipulate that programmatically using JavaScript. So we're kind of transitioning over. And what you're going to find is if you get done with this class or done with this program, you're like, man, I like JavaScript. I want to be a JavaScript programmer. You're probably not going to write a lot of applications like payroll applications in JavaScript. There are just other languages that are better suited for it, in my opinion. JavaScript is more a language that's going to be used for browser type of applications. All right, so that's kind of what we're going back to in here. It says we're going to learn to work with objects like text box objects. You already know what those are. So when they go through here, because there's a part of the chapter, when they go through and they talk about things like what is a text box, etc. I'm not going to go through those. The people from Muroc who wrote this book have no idea what your knowledge of HTML elements are. They have no idea that since you bought this book, you also bought their HTML book. How would they know that? All right, so anything that's in there like that, I'm not going to, I'm not going to go through it. Next, you'll learn how to code blocks of statements called functions, and you'll learn how to respond to events. You got to kind of look at it this way. Most programming languages, including JavaScript, are what are called event-driven programming languages. So imagine JavaScript is a person. Just imagine for a second, the whole language is a person. It's like you're sitting there like this all day long, waiting for something to happen, and then when that something happens, you react to it. And you do your thing, and you go back like this, and you wait for something else to happen, or that same thing to happen again. Those things that happen are events. And an event-driven language means that basically the language is responding continuously to events. You should already get this because really when you think about it, you've done some of this already. You have created programs or HTML things that have a submit button, a reset button. Those are responding to a submit event and a reset event. All right, so you've already at least seen some of this. You can respond to any kind of an event. What do I mean? Well, let's suppose for a second, in the olden days, like about 10 or 15 years ago, if I had created a form and I put on their age, okay, there wasn't a number type that they had in HTML. So what I'd have to do was I'd have to check programmatically to say basically if what you put in there, now you know what this is NaN, you wouldn't accept it. All right? So what I'm saying is it's not just buttons. It's not just buttons that have events associated with them. You can associate an event with almost anything that you put on a form, for example. All right. Says you'll learn how to respond to events that occur when a user performs actions. Again, clicking the button is probably the one that happens the most often. We've only looked at two types of buttons. Type equal submit and type equal reset. Guess what? You can just make a button. What does that respond to? Whatever the heck you tell it to respond to. And it responds whatever the heck way you tell it to respond. All right? So it says when you're finished with this chapter, you should be able to start developing your own apps. So we're going to talk about some of these. And again, some of these we've already looked at. Then, even if we get just that far before the break, that's fine. Then to show you how to use functions, the way I'm going to do that is, wow, right before your very eyes. I'm going to copy that program that we just did, that miles per gallon program. I'm going to copy it, and I'm going to redo it using functions. And then when I get done, I'll save a copy, and I'll print it out for all of you. All right, so you've at least got something that you can look at. So we'll talk about functions. Now, the easiest way to use functions may not seem like it, but at least probably the most intuitive way is to do function declarations. You say, I don't know what they are. You will in a couple minutes. What JavaScript allows you to do that most other languages don't allow you to do, let me say that again. What JavaScript allows you to do that most other programming languages don't allow you to do is you can take a function and put it on the left-hand side of an equal sign. So in other words, you can treat a function, which is a unit of work, like it was a variable. Those are function expressions. And as time has gone on, they've changed the way that you write function expressions. Why? Because as always, typically it means you write less code. So what will dovetail with its function expressions will be the use of what are called arrow functions. We'll get to that in just a bit. All right? All right, and then how to work with global, local, and block scope. If you don't know what that is, you will by the end of the period. Then we go into event handling. And notice they give it a whole spanking 6 or 7 pages. By no means are you expected to be an expert on this after 6 or 7 pages. All right? But we talk about how to attach an event handler to an event. So if we, for example, if we put our own button in there, we can go and attach an event handler to it. All right? How to use anonymous functions. What's an anonymous function? It's a function that you don't give a name to. Typically, it's a function you're only going to call it once. Some people refer to it as set it and forget it, because you call it once and boom, it's gone. You're not going to ever use it again. Typically, if you're going to call it over and over, you'll give it a name. All right? Then they'll talk about the event object itself, and then they'll go back and they'll rewrite the miles per gallon application using event handling. All right, and I think if you're going to learn something from this chapter, it's going to be a lot of it's going to be in there. So we'll take a little bit of time to go over it, and then we'll have an email list application. Why? Because we'll just ask for like 3 pieces of information: a name, and all we'll do is we'll say that you have to put something in there for the name. I don't care what it is, but you got to put something in there. Then you'll have an email address, and I don't remember if in this one, I don't think they even verified that it's a true email, but you again got to put something in there. Then you've got a confirm email address. So the confirm email address must match the original. So you'll see all that stuff programmatically. So that's what we've got to look forward to, I guess, in the chapter here. All right. Now, they said back in chapter 2, they talked about an object. I didn't spend much time on this, so let's just talk about it right now. All right. And I'm going to use a couple terms. One term that I'm going to use right away, the word class. Don't worry about it until the end of the semester. But when I say class, I don't mean like your class. All right? And the example that I always use is if you go out the lot where you're going on to par, not the one in the back that you want to, but that one, there's a bunch of land up there. And if you imagine that somebody bought that land, and they decided, we can fit 100 houses out here. All right? And they came up with 5 house plans. So they're going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now each house could have a different color. Some might have shutters, etc. But if you had house plan 1, it's going to look like this. Does that make sense? So then each one of those 5 house plans would be what's called a class. It's a blueprint for what you want things to look like. Each time you create an instance of that class, it's an object. So we're all objects. We're all human objects. We all have properties: a height, a weight, an eye color, a hair color. All right. I'm hoping I have a hair color for a while at least. All right. A gender, etc. We also all have methods: eat, drink, sleep, and we all get provided different things. I mean, I wish I slept 8 hours a night. Doesn't happen much anymore, but you get the idea. So when you call a method, often you have to provide it information. If I'm going to call an eat method, well, what do I want to eat? And the thing to realize about working with objects is they can only do what you give them the ability to do. So if we made a human object and we gave it an eat method, but we didn't give it a drink method, it couldn't drink. All right, something like that. All right, so it says here the objects that JavaScript provides are in two main categories. The first are host objects, says which are part of the environment in which JavaScript runs. So those are things that it has. And some of them, even though you don't think so, we've already used them. And if you say, I don't remember that, you're going to in a minute. If you look up on your screen here, it says host objects aren't part of the ECMA specification. May have mentioned this before, I may not have. I don't remember. But the thing is, if I asked you who is the governing body for basically all things HTML, you'd be right if you answered the W3C, the World Wide Web Consortium. They come up with recommendations that basically all browsers follow. If I said to you, what was the governing body pretty much for all things CSS, and you said, it's the same W3C, you'd be right. If I said, how about JavaScript? And you said, it's the same W3C, you're wrong. Because JavaScript is under the control of ECMA. And ECMA stands for European Computer Manufacturers Association. They typically come up with things that may or may not be massaged a little bit by the W3C, but that's when we make changes. Now, for years and years, most of the changes that were made, the ECMA-related changes, were not major. You wrote stuff the same way all the time. But really, since about 2015, there have been a lot of major changes. You've already been introduced to a couple of them yesterday. Remember that for in loop and that for of loop? Those are pretty new. Those are only 5 or 6 years old. Arrow functions that we're going to look at in this chapter, 5 or 6 years old. All right, but the idea at all times was to try to make the life of a programmer easier and easier. All right, so some of these objects, we've looked a little bit at arrays, but not much. Math objects, says you'll learn more about that in Chapter 12. Well, what does a math object have? Guess what? There's math.pi, pi. So it's math.P, capital I, paren, paren. And it gives you 3.14159 plus more decimal places. You've got math.floor, which says if I've got 5.9, math.floor says give me 5. It says throw away. Give me the lowest thing that's left. If I say math.ceil, C-E-I-L for ceiling, it does it the other way. It moves it up. There's math.square root, etc. There's a bunch of things that are built, and we'll look at some more of those later. All right. It says generally you don't need to know the difference between primitive type wrappers and the wrappers that make decisions on each one. Yeah, at least for what we're doing now. So this window object that you see in here, you don't need to use it because it's global. So in other words, would you agree we've used the alert method? Would you all agree with that? We could have said window.alert every time we said alert. But since window is baked in to the language, we don't have to do that. All right. We've looked a little bit at the document object, and I said you can use that to basically write the stuff on the screen. All right. Navigator contains information about the browser. People used to think, what's really cool about this? You know what I'm going to be able to do now? I'm going to be able to check that person's the type of browser they're using and the version of the browser they're using. And technically, yeah, you can do that. But when you think about all of the different types of browser software and all of the different versions, there's no way that you can sit there and write loops or whatever for each one of those because there's hundreds of them. All right. History is just that. Maybe you see shows like Law and Order where they think somebody's a sexual predator and they grab their computer. Why? Because they want to be able to see their history. All right. All right. Some of the native methods, you can see them right here. These are things, again, that are built into the language. All right. So, again, they show you could say const pi or you could use math.pi. Not a big thing. That's enough on that. So the window object, like I said, the only one that's in here that we haven't had before is this word confirm. Okay? So look at this. We use an alert. And it says, are you sure you want to delete this item? So they are asking you in that case with a confirm statement for confirmation. So if you click OK, it's gone. All right. And if you click cancel, nothing will happen. All right, then they talk about parse int, parse float. You already know what those are. And as it says, because the window object is global, you don't have to say window dot when you refer to it. All right. Then there's the document object. As it says, it's the highest object in what's called the document object model, or DOM structure. It represents the HTML elements for the page. You don't need to put the word document in front of them. We are going to look at this. Let's just take a couple minutes and then we will continue on with this probably after the break. Now, notice there's a query selector all, and we don't even care about right. All right, we care about these two. All right, you're going to see more than just the stuff that's shown here on page 129. But just imagine I've got a document, an HTML document that I've created with 3 paragraphs in it. Okay, let's just keep it simple. Let's say that's all that's in there. So I went to that lipsum.org that I showed you, and I put in 3 paragraphs. All right, if I use query selector and I put a P in there for paragraphs, it's going to find the first paragraph. So when you use query selector, it finds the first one that matches whatever you're looking for. On the other hand, if I say query selector all with a P tag in the middle, it'll find all 3 paragraphs. So if you're looking for just the first occurrence of something, you use query selector. If you're looking for all occurrences of something, you use query selector all. Are there other ways of doing it? Yes, and I'm going to show you those. Instead of using this, the query selector, just the query selector, all right? May have shown you this already, I may not have. I don't remember, but I'm going to show you this. So if I come through here, again, let's just say that I was making a form. I'm going to just keep this unbelievably simple, okay? And it's going to have one thing in there. So I'm going to say input type equal text. I'm not even going to go and give this a label or anything. I'm making this as simple as I possibly can. So type equals text, name equal, we'll say name, and ID equals name. Just like that. And we end that. You should know now that's going to make a text box on the screen and there'll be nothing inside of it. Does that make sense to you? So if I wanted to be able to get to that, I could use that query selector to find that. But another way I can do that, and the reason we use this right there, is there's another one that's called get element by ID. That's the other way that you can refer to something, and that's why you take anything that you may want to manipulate programmatically, and you give it an ID. Notice the capitalization. Don't capitalize the D. Most people do. You'll get an error because it's looking for a method with that name. And it's singular. It's not get elements. It's get element by ID. So you're going to see that later as we go on and we start talking about some of this stuff. So they show you some examples in here. Now notice this. Document.querySelector, you should be able to understand what that line means. That says I want you to find for me something with an ID of rate. If instead of ID, all right, it had a class of rate and there was only one of them, all right, or I wanted to just find the first one, it'd be a period there instead of a pound sign. Does that make sense? Same things that we used or we've been using for a while now. Look at this. This returns an array of object with all my A or anchor elements in there. I'm not going to run through each one of these, but you can take a look at them. And they get progressively harder. You can do multiple selectors, descendant selectors, etc. But guess what? We went through some of this stuff. These are all H2s that are within something with an ID of FAQS. All right? Very similar to what we've looked at previously. But like I said, please give this chapter a read because otherwise it's not going to probably make a lot of sense. And I think that out of the 5 questions that you have on your test, 2 or 3 are going to require that you create a simple form. 2 or 3 are just going to be kind of what we just did with the miles per gallon, where I just came up with a HTML thing and I included the source file. All right. So the DOM or document object model, all right, represents all the HTML elements of the page. You use query selector and query selector all to get a single object with query selector, or all of the objects with query selector all. It says, although the most common CSS selectors are shown above, there's other ones that can be used as well. All right. Very quickly, and I don't want to waste my time, your time. Text box, focus. So imagine again, I've got on my screen, I'm just going to keep it real simple. So here's my form, and it says first, and it says last. There's a text box here, and there's a text box there. There's a button here that says submit, and there's another button here that says reset. That cool, everybody? Does that make sense? If I take my mouse and I click in here, that now gets a focus event. It now has the focus. If I put my name in there and I hit tab and I go to here, two events take place. A blur event takes place right here, and a focus event takes place there. Why is that important? Because you can put code in a focus event or a blur event. So if somebody comes in here and let's say they leave it blank, or they put in a number, and now they hit tab, I can force them to stay in there if I want to. All right? And that's what they're talking about in here. There's also a select. Highlights, you know, you've seen that before, where it highlights everything. Okay? Value is grabbing whatever value is in there. Disable means that you know, so I didn't do this, but you're going to see it later for the miles per gallon program. The actual MPG, that text box will be disabled. You can't write in there. If I put in 300 for my miles driven and 15 for my gallons used, it's 20. Whether I like it or not, I'm getting 20 miles to the gallon. All right. The two fixed we've already looked at, so I'm not even going to say that. All right. There's date objects, there's string objects. The best thing I'll tell you about this, remember I gave you the first day we started on this on Monday, and I gave you that Hunlock thing, that URL. Hunlock's got a whole thing on dates. It's got a whole thing on strings. All right. And that's a great place to start when you're looking for these and which one to use. So the date, you can pull off any piece of the date. And usually the date also has the time in it. The weird thing about the date is notice the months. January is 0 and December is 11. That can be problematic sometimes for people. Are there ways around that? There's ways around everything. Here are some of the major string methods. The index of, the substring, etc. Those are all looking for something inside of a string. So if for some reason I gave you an assignment, and I won't, hey, go through the Declaration of Independence and see how many times the word the is in there. You could do that with some of these things. All right. The two lower and the two upper we've already looked at. So this is a good place to stop. I said it'd be around 9:10. So let's come back at 9:25. We're going to pick it up on using functions. And during the break, I'm going to do two things. I'm going to send you all the work that you're going to have in here for homework and labs. And I'm going to try to see if I can quickly go back and rewrite the miles per gallon program using functions. All right. All right, let's continue on then. Hopefully I didn't make any mistakes, but I rewrote this program and I use simple function declarations. But what I want to do first is run it, just make sure it works. And I want to explain every bit of it that's in here. Then we'll go into the part that talks about functions in the book. All right. So I got rid of the high and low MPGs. They were just clutter as far as I'm concerned. But I'm going to save this. And now I'll see, because if I've got errors, I'm going to have to quickly fix those. And it looks up. So 525. Oh, that's good. Run it again. Yeah. Gives me the errors. So that's good. That gives me the errors. All right. So that all appears to work. That's good. So what I want to do first is I want to go over the entire program with you. All right. So what I'm going to do quickly, hopefully quickly. Sometimes I wonder if I do anything quickly. But let's see, let's do it like this. Grab one of these things. And I'm going to put it at the beginning. To limit everything I'm doing in here. All right. Now, grab all this. Copy. All right, they should only be one page front and back, but we're going to go over this. And like I said, it appears to work. I guess I didn't do extensive testing on it right there. That's not good. That is really So it worked, except the second page, there's the second page with like 3 lines on it. Probably should have paused the page. So again, this is the same miles per gallon program, but it's been typically what's referred to as it's been modularized. In other words, I broke it down into individual functions. So I want to go over this with you. Remove that stuff that I put on the board earlier. All right. So as you take a look at it, I'm going to put it back here in Visual Studio Code. It's the same code. So you can see I use delimiters in there. You didn't have to do that, but now you can see where the constants start and end. You can see where the variables start and end. Notice when you look at these. All right, technically, there's a lot of ways I could have gotten around this, but I tried to keep this as simple as I possibly could right now. So I've gotten rid of the high MPG, I've gotten rid of the low MPG, and you go, yeah, you got rid of that thing called again and that one called more. Well, the again is here. The more and the FC are now down their local variables. Any variable, you don't have to write this down, but commit this to memory. Any variable in this language, and really in most every language, that you declare outside, any variable you declare outside of a function is global, meaning it's available to the whole program. All right. On the other hand, notice that in here I created a variable, I called it MD. That comes to life right here and it dies right there. And in the next one I wrote one called GU, and that's miles driven and gallons used, okay? And in here, when the run program again, same thing. Now we're declaring those variables right here. They come to life here, but they die when the method dies or the function dies. All right? So, taking it from the top, hopefully one thing you notice, look on the screen, please. This is the main part of the program right here. And in fact, quite often what you'll see in here is something like this. This will have a name too, function. And in many programming languages, it must be called main. So main is your point of entry. All right? So grab all this. Move that over. All right. But the idea behind main is like a supervisor. And I don't mean to imply supervisors don't do work. Of course they do. But a really, really good supervisor, and I'm privileged to work for one right now, and I've been privileged in the past to work for at least one other one. They know when there's stuff they can do, and they know when there's stuff that's better delegated to others. So what we're doing in here is in our main, we're just looping through and we're delegating the miles driven responsibility to this function. We're delegating the gallons used to this function. We're delegating calculating the MPG to this function. We're calculating displaying the miles to this function. And we're calculating whether or not to run the program again to that function. So main in this case is what is referred to as a driver. It drives the program. All right, so main calls the routines. So it says as long as I want to keep doing this, then set miles driven, set gallons used, calculate the MPG, display everything, and ask if you want to run it again. Now, I want to show you something, all right, and that is right here. I'm taking mine and I'm going to do a save on it. It's a little different than yours because I put the function main in there, okay? But I want to run this again. And I want to run it again. And I want to run it again. And nothing's going to happen because we never told main to be called. All right? We never in our program told main to be called. Well, one way I believe around that is I think we can come to the bottom of this program right here. I wouldn't do it there. I'd probably do it down here. And I can just say main. And that's calling that routine. So I don't know if that'll work. It should. And there it is. Got this guy named Spam Risk who keeps calling me every single day. All right. So now when I put main in there, I'm going to use a term that you haven't used before, but hopefully it makes sense to everybody. And that is, if you look up on the screen here, this line is referred to as a function invocation. I am invoking or calling the function main right there. If I didn't do that, since main is never called, it's like you put a button in a program, but you never click it. It's ready to do something, but you never told it to do anything. All right, so I'm invoking it right here, calling it, or I'll put in here also, it's known as a function call. Okay? So again, what I want you to get out of this is, first of all, these are considered totally proper. Those are considered totally proper. And what I mean by that is you can have constants that are global. That's considered to be totally fine to have constants that are global. These, technically, these are improper. And they're improper because you should never have global variables. Or, at a minimum, you should minimize your global variables. Having global variables opens you up to what are called side effects. All right. Imagine that they decided for one day that I could go and I could look at all of my information, my salary, all my information, and I could look at it. But accidentally they made it available so I could change it. So let's say that I'm not, but let's say I'm making $100,000 a year and I'm like, boy, I'm really underpaid. All right. So right before that 0.00, I should add another 0 in there because that's what I'm worth. All right. That's a side effect. Sometimes side effects are warranted. That's what you want to do. This is a side effect on miles driven. Does that make sense? I'm changing its value. This is a side effect on gallons used. This is a side effect on calculate MPG. But what if I did this? What if I came down into my MPG and I've got this? In fact, there's something This works. But where I've got this here, let's just say I change it again now and I say MPG equals, I don't know, 3. Okay, I just did that. Now I go and I run my program and everything looks like it's working. Okay, I drove 500 miles. I used 3, and it says my miles per gallon is 3. That's an unintended side effect. All right? And there's nothing wrong with doing that sometimes. But I'm always going to get 3 now as long as I put a number in here. All right? And it's even worse than that. What do I mean? Well, I just want to show you quickly. And I'm going to grab that line that says that it's equal to 3, and I'm going to cut it out of here. We don't want that in there. But I'm going to take that line, and right before I print out all that information in here, right before I print out all that information, now I'm going to put it back in. All right, just like that. And I'm going to run the program. And again, it comes in 500, 25, and 3. That's an unintended side effect. Because the only thing that should be able to modify miles per gallon is where I'm calculating the miles per gallon. Does that make sense? So I showed you both intended side effects and unintended side effects. Okay, and you're like, okay, that actually sort of makes a little bit of sense. Then how do you keep that from happening? Well, I'm going to show you right now. So, first of all, I'm going to get rid of this because we wouldn't want that. Okay? And second, I'm going to take these variables right here and I'm going to initialize them. I'm going to declare them and initialize them inside of main. It's going to mean I have to make a couple changes to my program. I'm going to show you those in a minute. But now I've got no global variables. Would you agree with that? Taking a look here, I've removed all the global variables. That's a good thing. However, now when I go in here and I start making some changes, okay, I've got here miles driven, and I define that up here. That's cool. I've got gallons used, and I define that in there. That's cool. I've got calculate MPG. Well, notice right now that MPG is gray up there. Can you see that? It's telling me that it's not technically being accessed. And what I'm asking you this question. Look on the screen here, because the answer is right on the screen. What 2 pieces of information do calculate MPG need? What 2 pieces of information does the routine need? Yeah. So now I have to do what's called pass these variables in. So I've got to say miles driven, and I've got to say gallons used. Because since I made those variables what are called local variables, in order to be able to pass them on to another routine, I had to literally pass them. All right. Now, display miles per gallon. Guess what that needs? Well, what are we printing down here? Display miles per gallon MPG. That's this. In fact, I think did I call it wrong? Nope, that's it. But I want to display what? Miles driven, gallons used, and MPG. It needs that information. Is what I'm saying, does what I'm saying make sense? If it doesn't, read the frigging book. And take a look, again, go out to the Mozilla Developer Network tutorial on JavaScript and or the W3 Schools tutorial. Or just Google, local variables and side effects, etc., and you'll see examples. All right. Now, that's all good, except down here, we're going to have problems. First of all, this return MD, let's see. Well, it says here, miles driven equals input miles driven. Actually, that should still be fine. Miles driven. I'm creating a new variable down here. This is my local copy of miles driven. I can call it miles driven, but it's less typing to type in MD. So I called it MD. That's totally fine. And I'm going to return this. Notice this return statement says, grab that MD and throw it in there. And then I do the same thing. I make a local variable called GU for gallons used. I manipulate it. I take its value when I'm all done, and I put it in here. Do both those make sense? Then I'm calling calculate miles driven. Right now, if I run this program, I'm going to get an error message. So I'm going to run it, and I'm going to see if for sure it should give me an error message. So boom, boom. Now nothing's happening. So I go and right mouse click in here. I choose inspect. I go over to my console. I go up to the top, and it says miles driven is not defined at calculate MPG line 75. So let's take a look and see what's at line 75. And it says I got MPG here. Doesn't know what the heck it is. All right. Well, remember in here, I said calculate miles driven, right? And it needs miles driven and it needs gallons used, correct? Well, now I can actually make this even easier. So I'm going to go down to this, and I'm going to call it MD for miles driven and GU for gallons used. Now, all I have to do is return miles driven, which is now called MD in here, by gallons used. Now it'll work. All right. Now, did I have to return it like that? I'm showing you different ways. You're going to see all of them in application code. All right. And I want to actually print out miles driven and gallons used and MPG, right? So down here, I'll need miles driven, I'll need gallons used, and I'll need MPG. MPG, I didn't change the name. This is now MD. This is now GU. And I need 3 parameters here because up here, I'm calling it and passing in 3 parameters. These parameters that you see here, miles driven, gallons used, MPG, they're referred to as actual parameters. You've got to use their actual name. All right, it's like when I sign something that's a legal document, I'm supposed to sign Jeffrey P. Scott. My wife will say, but they made the check out to Jeff Scott. I said, I don't care what they made it out to. When I'm asked for my signature, that's what I give. All right. Other than my late grandmothers, very few people in my life have called me Jeffrey. My mom when she's pissed at me. All right, but very few people. They call me Jeff. But you could say that's a nickname. No. In here, these are referred to as formal parameters. So the formal parameters can be the same name as the actual parameters. I could have called those miles driven and gallons used. And if it's easier for you to do that, then do that. All right? But let me show you real quickly why you might not want to do that. All right? I'm going to come down here again in my comments, and I'm just going to put in a couple more lines. And let's just say that let's pretend this is a brand new program, okay? And I'm going to say let A equal 10. Let B equal 15. Let C equal 20 or 30, fine. Let D equal 55. I'm just making those up. Now I'm going to write a quick function down here that's called add2. And I'm going to put in here N1 and N2. And I'm just going to say return N1 plus N2. All right. So I come in here and I go sum equals add2. And now I want to pass in A and I want to pass in B. All right. And then I'll just say alert sum. And that if I wrote that correctly, it should come back and say 25. That makes sense? Now I do it again. So I want to run it again, but now I want to call it with C and D. The reason that you oftentimes write functions is so you can call them multiple times in the program. But notice here it's A and B, and here it's C and D. I could have called them A and B down here, or I could have called them C and D down there, but it might be confusing. So I gave them generic names of N1 for number 1 and N2 for number 2. All right. So if a function is going to be called multiple times in the same program, then typically the names that you use for your formal parameters will be different than the names that you use for your actual parameters. Plus, I mean, imagine that I had this. So let's just forget all this stuff. Let's just say, and I don't care if this is called add to, it doesn't matter. All right. But let's just say for a second that I had 3 things that I was putting in here. And I call this federal income tax rate, and I call this state income tax rate. And I don't even know what the hell FICA stands for, but I don't care. It's federally insured corporation something or other, but I don't care. So let's just say that I put in here Social Security tax rate. Now, even with using an IDE like this, it'll remember those names. I'll just have to tab. But my lines are going to get really long. So if it's in a function, again, that infers that these are their formal parameters. So I'm just going to call this FTR for federal tax rate. I'm going to call this STR for state tax rate. And I'm going to call this SSNTR for my social security number rate. All right. It's going to make it much easier when I'm writing the program. That's all. All right. The other thing that I want to tell you about this is not a hard program. Even if you think it is, it really isn't. I'm going to grab this once I'm sure it works, and I'll make you a copy of that one too. All right. But the point is this. Let's pretend for a second this was a really, really, really complex program. And let's say that it had, I don't know, 50 functions in it. All right. And each function was an average of 100 lines long each. There's an unwritten rule that says when you write a function in an ideal world, every function that you write should fit on one screen, like this. All right. Now, tell you real quick, you might laugh. I did when I heard this, and maybe I've told you this already, at least to you guys, I don't know. But I had a student years ago who did this and said, "Hey, Mr. Scott," try that again. They said, "I got my function to all fit on one screen, by doing that." And yeah, but it was funny when I heard it. But the point is, in an ideal world, each function should be no more than about 20 or 25 lines. Is that the way it is in real life? Hell no. I've worked on programs where functions are thousands of lines long, not hundreds, thousands of lines long. But after a while, it tends to do what's called obfuscate the code. It makes it really hard to see where something starts and something ends, etc. So it's not that you can't do it, but maybe you shouldn't do it. The other thing is, again, so we said we've got 50 different functions. Now, I can say, okay, functions 1 to 10, James. Functions 20 to 30, or 11 to 20, Nick, etc. And now you can take the work and you can separate it. And that's the way a lot of actual programming is done. Not everything, but a lot of it is done that way. The bigger the shop, the more people you have to do the work. If it's a small shop, you're doing everything, and this doesn't mean a whole heck of a lot to you. All right. But let's save this. And I want to run it one more time just to make sure it works. And it's got my MPG as being undefined, so I'll have to check that. So that says in that MPG program, or that MPG thing, so return MDGU to fixed. Oh, that's good. See how it says return right here? You can put return in there and it's going to return that value. Would you agree? The problem is when I call calculate MPG, guess what? I'm not putting it into anything. So I should come in here and say MPG equals that. If you're going to go to the trouble of putting a return statement in, then it should have something it's returning it to. Now notice this one has no return statement because all it's doing is printing out my values. There's nothing to be returned there. All right, so let me try it again. And it appears to work. All right, so I'll print that out later. Don't worry about it. I promise I will. If I forget to for some stupid reason, just remind me and I'll print it out. All right, so let's jump back into the book then with that little interlude or whatever you want to call it. So, how to use functions. When you develop JavaScript applications, you need to handle all sorts of events. Everything I've shown you thus far has been simplistic in nature. You may not agree with that, but what I mean is we're not grabbing stuff from a form and doing stuff with it. All right? So a function is a block of statements that performs an action. That's a really important line right there. Look at this. Because there are some ramifications and people don't do what they're supposed to do all the time. I've used this example before. Okay, it's the first day of class. Okay, and using the computer, I have you enter some information about yourself. First name, middle initial, last name, address, city, state, zip code, cell phone number. Those 8 pieces of information. What this line of code is saying is I should take those 8 inputs and put them into 8 different functions. That way, if I have a problem with any of them, I know right where to go to. That's not how most human beings would do it. They would write it as one function. What you've got to watch out for and always be leery of is one function should not do too many things. All right. I could have done both the inputting of my miles driven and my inputting of my gallons used. I could have done them both in the same function. That's not the way you should write code, though. All right. So functions can receive parameters and they can return things. So this is the simplest way to write a function. It's what I just showed you. All right, nothing really new there. So function show year, and it tells you what the current year is. You call show year. Boom. Now, it gets a little more difficult. I'm on page 135. A function declaration with one parameter that returns a DOM element. Wow, what the heck does all this mean? We're not even going to talk about the $sign right now. It's what's called a shortcut, so don't worry about it. All right. Basically, what we're doing here is we are creating right here what is typically referred to as an alias. What this is saying is if we want to use in our code document.querySelector and put something in here, now we can just use a $sign. So if you go, I don't understand it, then don't use it. But I'd much rather type one character than all of those characters. So we're just creating, that's all we're doing. So notice this now, we can do it like this instead of saying const email1 equals document.querySelector and then that in parentheses dot value. All right. So here's a function, another one that has 2 parameters, and it's got a return statement. Notice this variable that we're creating right there, that tax, it's local because we've declared it, created it inside of there. Also notice they made it a const. Well, if I pass in a subtotal and a tax rate, all right, then the tax it's always. So if I got a 10% tax rate and I buy $100 worth of stuff, it's $10 of tax. And it always is. You could make that a const. It doesn't hurt anything to do that. All right. So a function contains a block of code that can be called, invoked by other statements in a program. What you put in parentheses are known as arguments. Sometimes they're called parameters. Some books call some of them parameters and some of them arguments, and some call the ones that Some call arguments, they call them parameters, and vice versa. All right, just depends on the book that you read. If you return a value from a function, it is a single return statement, and that's important. I wanted to show you this, and I didn't mention this before, so please go back and look at this right here. There. No. Where is? There it is. All right. Notice how there's one return statement in this thing called run program again. It's on line 101. Please look at the screen. Right here, right there. I could have said return false. It would have been totally fine to do that. I could have said return false right there. Program would have been dead in the water. All right? And then I could have said return true down here. You should always strive to have as few return statements in any function as you can, because it can lead to trouble. Because, oh, well, he put a bunch of returns in there, I'm going to add a bunch more. That's what happens when these functions get out of control. But now I created a local variable called retval, short for return value. That's no other meaning than that. And I set it to true. And I'm saying, hey, if you said you didn't want to do it again, I set it to false. So retval is either going to be true because this didn't get hit, or it's going to be false because this did get hit. But now there's only one return statement. That's the focal point. When it gets there, I can be guaranteed it's going to return true or false. It'll be true if line 96 was not true, and it'll be false if line 96 was true. All right. All right. Now, they mentioned here, and I'm saying this for completeness so you hear these terms. We may have talked about this the other day. On the bottom here, it says a function declaration is hoisted to the top of the file that contains it. It says because of that, it doesn't have to be coded before any statements that call it. Guess what? You already saw this. Would you agree looking at this? There's run program again, right? It's down on the bottom. Well, I called run program again right here. I called it before I even declared it, because JavaScript looks at everything and it says, oh, you belong at the top. You belong at the top. And it does that for you automatically. Not all programming languages do that. In some programming languages, I would have had to take in the run program again function and put it up above main. Not only that, I would have had to have put input gallons used above main, input miles driven above main, calculate MPG above main, and display miles, etc. above main. It just depends on the language that you're using. All right. Okay, now it gets harder. So if you thought, well, that was hard enough, well, it gets harder now, because this is function expressions. And as it says here, in the last figure, you learned how to code a function declaration. You can also assign a function to a variable or a constant. That's called a function expression. So let's look at it. Let's just look at this example. All right, right here. So what's different between this and what they showed previously? So I'm going to jump back a couple pages here. All right, so kind of, for lack of better words, keep this right here in your head. See this? So function, show year, okay, and then you call show year. See that? All right, pretty simple. It's only 4 or 5 lines. I can't copy anymore from this goofy thing. It won't let me. So now look at the difference. Now, instead of saying function show year, you say const show year equal function. The difference is show year is now a variable. Before it was a function call. Now it's a variable that holds the results of that. That's considered to be more dynamic. And in certain kind of code that you write, it'll execute faster, better if you do it this way. Virtually, every time you write a function using a function expression, you could also write it as a function declaration that we looked at earlier. All right? All right. So as it says, a function expression is typically assigned to a constant and then referred to by that constant's name. but it can also be assigned to a variable, meaning you could use let or const. Although a function expression isn't typically given a name, it can have one. All right. Now, here's a big difference. In contrast to a function declaration, a function expression is not hoisted. So it's not pushed up to the top. So we could go back and rewrite this program, and I'll try to do that for tomorrow. So I'll try to rewrite this program that you've got right here, and I'm going to try to rewrite it twice. Once with function expressions and once with arrow functions. So you can see all of the stuff that we've done in action, so to speak. All right. So the arrow function, and again, it's fairly new. All right. Let's see. This is a great example they give right here, page 139. Now, here they say const calculate tax. Here they say const calculate tax. Looks the same. Here it says equal function, then you've got your parameters. Here it says equal, and you've got your parameters, but you don't have the word function. Instead, you put in what's called a fat arrow. An equal sign followed by a greater than sign, and then your curly braces. Right there. All right. So, why is that important? Is that important? This is the way virtually you'll write all of your code when you get to the third semester and you're in the AWD 1111 class. For Node.js, it's virtually written like this. In fact, when I give students examples, they'll tell you, I'll literally come in and I'll do this. You know, I'll come in there and I'll remove that, and I'll come in here and I'll remove that, and I'll put in the fat arrow and then that. They'll see that all the time on the stuff that I do. This will still work, but it's considered the old-fashioned way of doing it. And I want to mention a couple things about this. Okay? First of all, if there's only one parameter, we're going to pretend that's not there. Pardon my bad artistic work here. If there's only one parameter, you don't need the parens. See that? You don't need any parentheses. All right? If there's no parameters, you do need parentheses. If there's two or more parameters, you need parentheses. Many people will say, even if there's only one, they'll still use the parens. And if that makes it easier for you, do it that way. The other thing is, just so you know this, let's assume for a second, I'm going to rewrite this right here. I'm just going to say const, let's use the one that we had before. So const add 2, and we brought in n1, and we brought in n2. All right, then we have our fat arrow, and then this, and let's just say we want to say return n1 plus n2. And guess what? That will work just fine. Not a problem. However, there's even a shortcut for this. All right, and the shortcut is this. Const add 2 n1 n2 fat arrow. Since it's just returning, all you have to say is n1 plus n2, and the word return is implied. So I've taken 1, 2, 3 lines of code and made it into one line of code. Now, I don't expect that to totally resonate with you. And if you don't remember that, it's no big thing whatsoever. It isn't. We're going to probably do very little with arrow functions in this class. But at the end of the semester, when I talk about the stuff that's in the 1111 class that you take third semester, it's almost all arrow functions. All right? Not exactly sure why they decided to explain them right here, but since they did, I decided to do the same thing. So you can read that. And the explanation for all of it, I basically gave it to you, but it's all right here. All right. Now, local, global, and block scope. Guess what? We've talked about this a little bit already. So, does it make sense to you that those two variables where it says two global variables, they're global because they're not defined inside of any function, so they're automatically global. If I come in and write a routine, here This is local because I'm declaring it inside of here. All right? So when something's got global scope, it's available program-wide, and we don't have to pass it like I showed you passing things earlier. If something is local and I'm in one function and another function needs it, I must pass it. All right? Then there's block level. So you may or may not know this, but remember when we wrote a for loop like this? So I write for, and I said something like let I equals 1, I less than or equal to 10, plus plus I. And then let's just say we do an alert here. So this is going to give me 10 different alerts. I don't care. Does that make sense to everybody? When you talk about block scope, if I try to come down here and say alert I'm going to get an error. And the reason I'm going to get an error is I defined it within curly braces. So this begins life here and it ends life there. So if I want to be able to use I once I get out of here, then I've got to come up here and say let I equal 1. Then I wouldn't even need to put it in here. I could just do that. Then I can use it down there, but otherwise I can't. So global scope means it's available program-wide without having to pass it. Local scope means it's been defined inside of a function, and if I want to use it in other functions, it has to be passed into those other functions. And block scope means that it is defined within curly braces, so it begins life at the beginning curly brace and it ends life at the ending curly brace. All right. And again, you can read. I get sick of reading to you. So, all right. So let's see. Well, I'm going to stop this right here. It's a little bit early for another break, but before I'm going to give you one in just a second. And before I do, I just want you to see this. I can keep taping. It's not going to matter. But I did send you all. I think I did. Did I send the email out yet? Thought I did. Yeah. Let's see. Yeah, I should have. I guess I didn't include myself on it. So let me look at my sent items. Yeah. So I sent you, and we'll look at this once we finish the chapter, but it's got your homework and it's got your labs in it. All right. Some of the chapters, you're only going to have 1 or 2 programs. Some you'll have more. I tried to make sure, and this is for Mr. Wharton's especially, that all the starter files, I tried to make sure they were all in there, because I know this book has a tendency to not put them in there. And honest to goodness, I appreciate it when you let me know when they're not there. Then I can send them out to everybody right away. But as far as I know, everything I gave you is in there. So it is 10:11. Let's come back, please, at 10:25.